In Class Roman II, Division 1 locations, understanding the National Electrical Code, or NEC, requirements for conduit seals is critical for ensuring safety and preventing the propagation of flammable vapors or gases. The NEC Section 501.15 B2 B specifically addresses this, stating that seals shall be provided where conduits, cables, or raceways enter or leave the enclosure. This requirement applies to both rigid and liquid-tight conduits. The primary purpose of these seals is to create a vapor-tight barrier, preventing the movement of flammable substances between the inside and outside of the enclosure. Now, let's clarify the difference between sealoffs and ductseal, and why sealoffs are essential in this context. Sealoffs are specialized fittings designed to provide a vapor-tight seal around the conduit or cable as it enters or leaves the enclosure. These fittings typically use a rubber or neoprene gasket which compresses against the conduit or cable when the fitting is tightened, creating a secure seal. Ductseal, on the other hand, is a type of sealant used to fill gaps and voids around conduits, cables, or raceways. While ductseal is useful for preventing the ingress of dust and moisture, it is not a substitute for sealoffs and does not offer the same level of vapor-tight protection. Therefore, simply using ductseal at the end of liquid-tight conduits within the device enclosure is not sufficient to meet the NEC requirements. For correct installation in a Class Roman II, Division 1 location, you must use sealoffs at the end of both rigid conduits. These sealoffs should then be sealed with ductseal to further enhance the seal. The liquid-tight conduit should be connected to the sealoffs, and the ends of the liquid-tight conduit should also be sealed with ductseal. This multi-layered approach ensures a robust vapor-tight barrier. To reiterate, simply ductsealing the end of each liquid-tight conduit in each device enclosure is an incorrect installation. This method does not provide a vapor-tight seal and could allow flammable vapors or gases to escape or enter the enclosures, posing a significant safety risk. In summary, when working in Class Roman II Division 1 locations, always prioritize the use of sealoffs at the conduit entry and exit points of enclosures. Supplement these sealoffs with ductseal to maximize the vapor-tight protection. Adhering to these guidelines ensures compliance with the NEC and promotes a safer working environment. Let's delve deeper into the specifics of installing sealoffs and using ductseal in Class Roman II Division 1 locations, ensuring a comprehensive understanding of the NEC requirements. Firstly, select the appropriate sealoff fitting for the conduit size and type you are using. Sealoffs come in various sizes to accommodate different conduit diameters, and it is crucial to choose the correct size to ensure a proper, tight seal. Secondly, prepare the conduit ends by cleaning them thoroughly. Remove any burrs, sharp edges, or debris that could compromise the seal. A clean and smooth surface is essential for the sealoff to function effectively. Thirdly, install the sealoff fitting onto the conduit. Follow the manufacturer's instructions carefully, as the installation process may vary slightly depending on the specific type of sealoff. Ensure that the fitting is properly aligned and tightened to the specified torque to achieve a secure connection. Fourthly, once the sealoff is installed, apply ductseal to both the conduit entry and exit points of the sealoff. Hack the ductseal firmly into any gaps or voids to create an additional barrier against the ingress or egress of flammable vapors or gases. Fifthly, connect the liquid-tight conduit to the sealoff. Again, ensure that the connection is secure and tight to maintain the integrity of the vapor-tight seal. Sixthly, apply ductseal to the ends of the liquid-tight conduit where it enters the device enclosure. This final layer of sealant provides an extra measure of protection against the potential escape of flammable substances. Now let's address some common misconceptions and potential pitfalls to avoid when working with conduit seals in Class Roman II Division 1 locations. One common mistake is over-tightening the sealoff fitting. While it is important to ensure a tight connection, over-tightening can damage the fitting or the conduit, compromising the seal. Always follow the manufacturer's instructions regarding torque specifications. Another pitfall is using the wrong type of sealant. Ductseal is specifically designed for filling gaps and voids, but it is not a substitute for a proper sealoff. Using other types of sealant that are not vapor-tight can create a false sense of security and fail to meet the NEC requirements. A third mistake is neglecting to inspect the sealoffs regularly. Over time, seal-offs can deteriorate due to environmental factors or physical damage. Regular inspections can identify potential problems early on, allowing for timely repairs or replacements. In addition to these installation and maintenance considerations, it is also important to understand the broader context of electrical safety in Class Roman II, Division 1 locations. These locations are characterized by the presence of combustible dusts, which can pose a significant explosion hazard. Therefore, all electrical equipment and wiring must be specifically designed and installed to minimize the risk of ignition. This includes using explosion-proof enclosures, intrinsically safe circuits, and other specialized safety measures. It is also important to note that the NEC is not the only standard that governs electrical safety in hazardous locations. Other relevant standards may include those issued by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, the International Electrotechnical Commission, or IEC, and Occupational Safety and Health Administration, or OSHA. Familiarizing yourself with these standards can provide a more comprehensive understanding of the safety requirements in Class Roman II, Division 1 locations. Furthermore, ongoing training and education are essential for electrical professionals working in hazardous locations. Staying up to date with the latest codes, standards, and best practices can help ensure that installations are performed safely and effectively. Consider attending industry conferences, workshops, and training courses to enhance your knowledge and skills in this specialized area. To recap, proper installation and maintenance of conduit seals are critical for preventing explosions and ensuring safety in Class Roman II, Division 1 locations. Always use sealoffs in conjunction with ductseal, and avoid common mistakes such as over-tightening fittings or using the wrong type of sealant. Stay informed about relevant codes, standards, and best practices, and invest in ongoing training and education to enhance your expertise in this specialized field. By following these guidelines, you can contribute to a safer working environment and minimize the risk of electrical hazards in hazardous locations. Let's explore some additional considerations related to the specific types of devices and equipment that may be installed in Class Roman II, Division 1 locations, and how these factors can influence the selection and installation of conduit seals. Firstly, consider the operating temperature of the devices. Some equipment generates significant heat during operation, which can affect the performance and longevity of the sealoffs and ductseal. Choose materials that are rated for the expected temperature range to ensure a reliable seal. Secondly, consider the chemical compatibility of the materials with the surrounding environment. In some Class Roman II, Division 1 locations, corrosive chemicals or other substances may be present, which can degrade the sealoffs and ductseal over time. Select materials that are resistant to these chemicals to maintain the integrity of the seal. Thirdly, consider the vibration levels in the location. Equipment that vibrates during operation can cause the sealoffs and ductseal to loosen or wear out prematurely. Use vibration-resistant sealoffs and ensure that the connections are properly secured to minimize the effects of vibration. Fourthly, consider the accessibility of the sealoffs for inspection and maintenance. Choose locations that allow for easy access to the sealoffs so that they can be inspected and maintained regularly. Avoid placing the sealoffs in areas that are difficult to reach or require special tools to access. Fifthly, consider the potential for mechanical damage to the sealoffs. In some locations, the sealoffs may be exposed to physical impacts or other forms of mechanical damage. Protect the sealoffs with guards or other protective measures to prevent damage and ensure their continued functionality. In addition to these device-specific considerations, it is also important to consider the overall system design when selecting and installing conduit seals. For example, the number of conduits entering or leaving an enclosure can affect the size and type of sealoffs that are required. Similarly, the routing of the conduits can influence the placement of the sealoffs and the need for additional support or protection. It is also essential to coordinate with other trades involved in the installation process, such as electricians, instrument technicians, and mechanical contractors, to ensure that the conduit seals are properly integrated into the overall system. Effective communication and collaboration can help prevent conflicts and ensure that the installation is performed safely and efficiently. Finally, remember that the NEC is a living document that is updated regularly to reflect changes in technology and best practices. Stay informed about the latest revisions to the code and ensure that your installations comply with the most current requirements. Consult with qualified electrical inspectors and engineers to clarify any questions or concerns you may have about the NEC requirements for conduit seals in Class Roman II Division 1 locations. By paying attention to these details and working collaboratively with other professionals, you can help ensure that electrical installations in hazardous locations are performed safely, effectively, and in compliance with all applicable codes and standards. Let's examine some specific examples of how these principles apply in real-world scenarios. Imagine a grain processing facility where combustible dust is a constant presence. In this environment, electrical equipment such as motors, switches, and lighting fixtures must be installed in explosion-proof enclosures to prevent the ignition of dust clouds. Conduit seals are used to maintain the integrity of these enclosures and prevent the escape of flammable dust particles. In this scenario, it is crucial to select sealoffs that are specifically designed for use in Class Roman II Division 1 locations and that are resistant to the abrasive effects of grain dust. The sealoffs should be inspected regularly to ensure that they are not clogged with dust or damaged by mechanical wear. Similarly, consider a chemical manufacturing plant where flammable vapors or gases may be present. In this environment, electrical equipment must be installed in enclosures that are designed to contain any internal explosions and prevent the ignition of surrounding flammable atmospheres. Conduit seals play a critical role in maintaining the integrity of these enclosures and preventing the propagation of flames or explosions through the conduit system. In this scenario, it is important to select sealoffs that are rated for the specific flammable substances that are present and that are resistant to chemical corrosion. The sealoffs should be installed in accordance with the manufacturer's instructions and inspected regularly to ensure that they are functioning properly. Another example is a wastewater treatment plant where methane gas, a flammable byproduct of anaerobic digestion, may be present. In this environment, electrical equipment must be installed in enclosures that are designed to prevent the ignition of methane gas. Conduit seals are used to maintain the integrity of these enclosures and prevent the escape of methane gas into the surrounding atmosphere. In this scenario, it is essential to select sealoffs that are rated for use in hazardous locations where methane gas is present and that are resistant to the corrosive effects of wastewater. The sealoffs should be installed in accordance with the applicable codes and standards and inspected regularly to ensure that they are functioning correctly. These examples illustrate the importance of understanding the specific hazards present in a Class Roman II Division 1 location and selecting conduit seals that are appropriate for those hazards. By taking a proactive approach to safety and following best practices for installation and maintenance, electrical professionals can help prevent explosions and protect lives and property in hazardous locations. Furthermore, consider the advancements in technology that are continually shaping the landscape of electrical safety in hazardous locations. New types of sealoffs, enclosures, and wiring methods are being developed to improve safety and efficiency. Stay informed about these innovations and consider adopting them when appropriate to enhance the safety of your installations. For instance, some manufacturers offer sealoffs with integrated monitoring systems that can detect leaks or other problems and alert maintenance personnel. These systems can help prevent catastrophic failures and improve the overall reliability of electrical installations in hazardous locations. Similarly, new types of explosion-proof enclosures are being developed with improved ventilation and cooling systems to reduce the risk of overheating and ignition. These enclosures can help extend the lifespan of electrical equipment and improve the safety of the surrounding environment. In addition to these technological advancements, there is also a growing emphasis on training and education for electrical professionals working in hazardous locations. Online courses, workshops, and certifications are available to help electricians, engineers, and other personnel stay up to date with the latest codes, standards, and best practices. By investing in training and education, companies can improve the skills and knowledge of their workforce and reduce the risk of accidents and incidents in hazardous locations. In conclusion, ensuring electrical safety in classroom and to Division 1 locations requires a multifaceted approach that encompasses proper installation, maintenance, technology adoption, and ongoing training. By following best practices and staying informed about the latest advancements, electrical professionals can help prevent explosions, protect lives and property, and create a safer working environment for everyone. Remember, safety is not just a matter of compliance, it is a fundamental responsibility that we all share.